Okay, so what if a massive, super powerful AI could teach all of its secrets to a tiny little model, one that could fit right in your pocket? Well, today, we're diving into this really clever new framework that's making that exact thing a reality. And trust me, it's changing how we think about AI efficiency.
And when I say gigantic, I mean gigantic. We're talking about deep neural networks with hundreds of millions, sometimes even billions of parameters. All that raw power, though, it comes at a super high cost. You need massive server farms, tons of memory, just to keep these things running.
Right, this brings us to the big dilemma for pretty much every AI developer out there. How in the world do we bridge the gap between these incredibly smart cloud-based AIs and, the practical, real-time apps we all want on our phones? That is the exact challenge this research is tackling head-on.
All right, let's really get into it and break down this core challenge. It all comes down to this fundamental trade-off between an AI's raw power and, well, its usefulness in the real world. And this leads us to what's basically the AI paradox. See, as these deep neural networks get smarter and smarter, they also get way heavier and more expensive to run, so the big challenge is to compress them, right? Make them leaner without losing all that intelligence that makes them so dang useful in the first place.
So to try and solve this, a really clever solution popped up a few years back, and it's built on a super simple analogy, something straight out of the classroom, the good old relationship between a teacher and a student.
The whole idea behind this thing, called knowledge distillation, or KD for short, is honestly pretty elegant. You just take a big, clunky, but super expert model, that's your teacher, and you have it teach a smaller, quicker student model everything it knows. And what's cool about this is that the student doesn't have to learn from all that messy, raw data from scratch. Nope. Instead, it learns directly from the refined wisdom of its teacher, basically from the teacher's final answers. It's kind of like getting a perfect set of Cliff's Notes instead of having to read the entire massive library yourself.
But, and there's always a but, right? Here's the catch. What if the student model is just too small? If its capacity to learn is really limited? Well, in that case, the teacher's super complex lessons can be totally overwhelming. There's a technical term for it, overregularization, and it can actually stop the student from learning properly at all. Okay, and this is where our new framework, Knowledge Representing, or KR, comes into the picture. It brings a totally different approach to teaching these small models, and it's a real game changer.
And this slide really gets to the heart of it. It's a huge shift in philosophy. See, traditional KD is all about the student copying the teacher's final answers, the what. But knowledge representing, it's different. It focuses on the teacher's internal thought process, the how. It's the difference between just memorizing facts for a test and actually learning how to think and reason for yourself.
So, the big question is, how does KR actually do this? Well, it relies on two really innovative secret ingredients that work together to make this teaching method so much more effective.
Okay, ingredient number one is something called knowledge aggregation. The whole point of this is to give the student the big picture. So instead of just flooding it with a million tiny details from every single one of the teacher's deep layers, it merges and summarizes them into bigger, more digestible ideas.
Yeah, it's just like this quote says. Think of it like summarizing a bunch of dense textbook chapters into a handful of concise, big idea notes. This whole approach stops the student from getting lost in all the tiny details and makes sure that the most important, high-level patterns from the teacher's brain get passed on nice and clear.
All right, on to ingredient number 2, the sparse recoding penalty. Now, penalty might sound harsh, but it's really just a clever way to help the student focus. It basically guides the student's limited brain power towards learning the most critical stuff first. It's all about boosting the important signals and filtering out the noise.
And this is just like having a tutor highlight the absolute most important concepts you need to study before a big exam. This penalty makes the whole learning process incredibly efficient. It zeroes in on the most dominant bits of knowledge and tells the student, hey, pay attention to this, so it doesn't get distracted or overwhelmed.
So, the million-dollar question, does this new teaching method actually work in the real world? Well, the researchers put it to the test, and yeah, the results are pretty darn impressive.
Check this out. So, on a standard test, a regular student model scores about 88% accuracy on its own. Not bad, but get this, that same model, when it's trained with this new knowledge representing framework, jumps all the way up to over 90.6%. That is remarkably close to the giant teacher model, which is sitting at just under 92%.
And here's the kicker. This shows the incredible efficiency gain. The student trained with KR doesn't just get smarter, it actually gets smaller. In the experiment, it hit that super high accuracy while having about 25% fewer parameters than the other student models. We're talking more power in way less space.
So, what's the big takeaway here? It's that KR creates these smaller, faster, but still incredibly powerful AI models because it teaches them how to think, not just what to know. It's about distilling the very structure of that knowledge into a much more efficient form.
And all of this leads us to one final, really exciting question. This kind of research is pushing us way closer to a future where the most advanced AI isn't stuck up in the cloud somewhere. It's accessible to everyone, everywhere. So, what new possibilities open up when that level of powerful AI can run efficiently on any device you've got right in your pocket?